Welcome to Func Prog Sweden, everyone. And today we are at Kivra, and we are both at Kivra, and we're also sending live to YouTube, so be aware. I'll kick off the presentation with first up the agenda today. I will do a short introduction as always, and then I'll hand over to Christoffer, who will talk about why pure functional programming matters. Really important topic. Yes, but first, we would like to thank our venue sponsor, Kivra. Very grateful, very great food. I think this time you've overdone it. I've already had people said, wow, this is even better than last time. Wow, it's amazing. Thank you very much. I would also like to say that Kivra is looking for people. So if you're into Kotlin, if you're into Go, and of course, if you're into Erlang, they are looking for Erlang people. But I also heard that they are looking for some VP role also. So if you want to know more, head over to kivra.se and find careers, I guess, where you can find all the jobs. So again, thank you very much, Kivra. Next, thank Otterbeat. I work at Otterbeat, so thank you very much, Otterbeat, for sponsoring the video stream. If you want to know more about Otterbeat, head over to the webpage. Very simple, otterbeat.com. First step, yes. Cheers. Then, schedule for the upcoming months and year. 9th of December, we're gonna run the next meetup. It's just gonna be an online meetup. Then we haven't decided the meetup date yet for January and for February, but we have decided one thing, that in October next year, we're gonna run another conference. For those of you who were there we ran a conference on 15th of October this year called Func Prog Conf. We're gonna run it again next October. And this time it's going to be a full day conference, not just a half day conference. It's still going to be one track, and we're going to be at an amazing venue. I'm not going to tell you where it is. So head over to the funcprogconf.se if you want to know, and if you want to get more information, head over, sign up your mails. Right. Then, of course, if you want to support the meetup group, head over to Meetup. Make sure to become a member, and also make sure to subscribe to our YouTube channel. And of course, you can also head into the Discord server. I know some people, usually when I tell this, I see some people joining the Discord server. And the Discord invite is available both, I think, on the Meetup group and in the YouTube channel. Oh, and if you have any questions during the presentation, just in the audience, I don't know if Christoffer wants presentations when he's doing his presentation. Would you like questions when you do your presentations, or? Yes. Thumbs up. So if you have questions during the presentation, please raise your hand, and I will send over a mic to you, so the people online also hear your questions. And if you have questions online, shoot them in the chat, and I will read it to Christoffer. With that, let's start. Warm welcome, Christoffer.
Woo! Is this thing? It's on. It's on. I can tell. Okay, let's see. Okay. Oh wait, sorry. I'm gonna start from the beginning. That's usually a good idea. Okay. Yeah. Okay. Yes. Yeah. Hello, Func Prog. How is everyone doing? Yes. Oof. Okay. So the title of today's presentation is Why Pure Functional Programming Matters. And I will try to explain it in a way that your boss will understand. So after this presentation, you can take this to your boss and convince them to use functional programming. Well, I can't promise anything, but okay, so imagine this. This is your boss, right? And the moment you've been waiting for your whole career, they're starting to ask you about functional programming. Why? Why should we care about this? And then you need to be prepared, right? And this is you. And so what should you reply with? Well, the title of this presentation is inspired by a paper by an influential person in the FP world called John Hughes. And he wrote a presentation, or he wrote a paper called Why Functional Programming Matters. And he highlighted a bunch of things about FP that are all really good, like, you know, the higher order functions can be used to increase modularity. Lazy evaluation means that you're very free to structure your program any way you want. Immutable data and pure functions make programs easier to reason about. And what I want to dig into tonight is really this last point, because while those other things are great in and of themselves, I think like the key part is actually making programs easier to understand. And so I want to start this by like try to dig into like okay, why in my opinion it's not like it's a bit hand wavy to say, oh, it's just better. So I want to try to show you how mutability and like side effects can make programs hard to understand. Okay? Because the bottleneck when creating software, especially in like a collaborative environment with lots of coworkers, etc., is not the pace at which you can produce new software, because that's limited by the pace at which you can understand old software. So, quiz time. Okay. And now you just shout the answer, whenever you think you have it. I'm just going to say, like, I'm not going to tell you the programming language. But like this is a very simple equation. So what should this evaluate to? True. I'm hearing true. Yes. I mean, of course it should be true. I mean, how could it not be? Like, obviously, unless you're using JavaScript, then you can do something like this. And I mean, of course, 1 plus the string a is 1a, right? Oh, duh. How could I not think of that? I mean, okay, and this is like this joke is a bit tired by now, even like, you know, haha, JavaScript, like what, etc. So let's try this again. And I'm going to tell you that this time this is in C#. And C# is statically typed, right? So there can be no like funny like coercion shenanigans. So what should this evaluate to? I hear one false, but I mean no way this isn't true, right? I mean we can't do the funny thing with the types anymore. Like no strings plus numbers, etc. But it turns out it can be false. If you create a custom class for numbers that overrides the plus operator and makes it so that it mutates the input argument. And now you might object and say, well, that's a silly example. Like, but this is something that happens all the time when you have mutable state. Like you might not think about it, but you end up mutating the input argument. And the caller has no idea that you just did that. And you can notice that, like, even though this should be really obvious, like what that expression evaluates to, like, we couldn't tell without knowing additional context. Like, even though it was a trivial expression. And the problem becomes that if we can't like just sight read the expression, we need to understand what all the functions that we call, what they do. And we need to understand what the functions, those functions calls do, etc. So in aggregate, the cost of change becomes dependent on the size of the code base. And like, you know, if you've studied complexity theory, you know that, like, I mean, of course, most of the time you will not have to read through the entire code base just to understand a single expression. But, you know, if you know your complexity theory, you know that what matters most is the worst case. So that means the complexity of making a given change in a code base with n lines of code is OM, which is not great. And I mean, you might think this is like hyperbole. Is it really that bad? Well, according to this survey made by SourceGraph in 2020, I think they surveyed like over 500 software companies. 75% of respondents said that they were afraid of making changes to their code base because they thought they might break something. So this is not just a hypothetical. I think we're actually like getting at something here. And if you want to illustrate this, you can view it like this: like as the size of the code base grows, the cost of change increases, and progress starts to slow down. And eventually, it halts completely. You can see the red line here is like the progress you're making on your tickets and features or whatever. And you can see that as it starts to become harder to change the code base, the rate of progress slows down. And there are a bunch of ways you can solve this, like microservices, for example. And the thing that does by breaking out things to a service is basically it lets you restart the clock. So you restart the timer to 0, you start over in a new project, but it's still just like deferring the same problem. And I mean, I think a lot of you recognize this. As the code size of the code grows, it seems like things start taking more and more time all the time. And this is the reality of most software projects. Okay, so let's say that we all agree that mutability is bad. It makes code harder to reason about. And functional programming fixes this in different ways depending on which programming language you're using. Some disallow mutation entirely, like Haskell, but most of them discourage it or force you to make it explicit when you are mutating something. And another nice thing about a lot of these languages is that they use persistent data structures like linked lists, trees, etc., that make this kind of copy and write semantics cheap. Okay, so let's move on to another problematic thing. We've covered mutation. Let's talk about side effects. So, I mean, this time for sure, I promise I won't do that. Oh, sorry. I know I will do the trick again, the operator overloading. Because there's nothing preventing me from just putting an exception anywhere in the code. And even though C#, like I said before, it's statically typed, there's nothing in the type signature telling me that it can throw exceptions. So I better read the documentation carefully or read the source code in the worst case. So yeah, as you might guess, this will never return true or false or anything. It will just crash. And functional programming, again, helps us here by discouraging all kinds of side effects, at least without proper annotation. And so even if you're not using a functional programming language, you should strongly consider not doing this kind of things with exceptions. A lot of programmers like to model control flow with exceptions, for example. Probably not the best idea. Try to use errors as values instead. And most programming languages have support for some kind of result type that you can use instead to signal that something went wrong. So, so this time we're working with Java. So this is Java code, and Java does not allow operator overloading. So I can't pull that trick on you again. And Java, it only supports, because it doesn't support overloading, this should only be plain regular arithmetic, plus, minus, etc. So no funny business. So I mean, this should be true this time, right? Then, so it turns out that since Java does something called autoboxing, if you have like an object that should work like a numeric type, it can automatically convert back and forth between that type. So if you have an expression, well, like the one below, you can actually get it to throw a null pointer exception. And I mean, this is not unique to Java. Like Scala has some very funny semantics for when you try to do arithmetic with null pointers, and like, you know, F# has the same problem. I think like it's probably only Haskell where you're sort of immune to this. Okay, but how can, and this is a bit interesting because a lot of functional programming languages don't really have a fix for this. I mean, do we have any Lisp programmers in the audience? Good, because they might get angry at me. Like, my opinion is that you should not use null. Like, even the guy who like brought us null, Tony Hoare, says it was his, like, you know, his $1 billion mistake. Like, you know, something's bad when even the inventor says, like, okay, this was a terrible idea. But okay, so if your language has option types, use those, and like there's lots of like null safety features in modern languages nowadays. So please use those instead. And if you can't, at least try to like eliminate null at the boundaries of your program. Like if you need to accept data that's nullable, try to sort of like clean that up before it enters the rest of the system. So okay, and now a lot of the things we have looked at so far is sort of like things you get for free when you use most functional programming languages. But this one is kind of like, how can I say, like input output. How should we deal with that? And of course, like since if you go back to the C# example, since I can put anything I want in my overloaded method, I can launch missiles, for example. And again, like this doesn't show up in the type signature. I have no idea that this is happening. You know, basically anything can happen. But I mean, this example is a bit crazy, right? I mean, no one would put a side effect or like no one would put IO in a simple math function, right? I mean, that would be crazy. But guess what this evaluates to? Oops. Yes, another side effect. But if you can see here, okay, we have two, this is in Java, and this is from the standard library. We have two URLs, one that's like domain and an IP address. And if you compare these, it will actually return true. Why? Because where the URL.equals method in Java actually does a DNS lookup. And I think I'm connected to Wi-Fi right now. But if I wasn't, this function would fail. Like it would crash, saying like, you know, oh, it couldn't resolve the DNS server. So this actually does happen like more than you would think. And it's very easy to sort of like sneak these things in without like, you know, without noticing. Just to like, you know, give you a like, more realistic example. This is something from my favorite programming language, F#, at least at the moment. And like, you know, okay, so even if you can't read, or even if you don't know F#, you can probably read what this does. Like, we have the function is called validate email. It takes a string as an input, and then we get the result back. So the result can either be like okay or error. And you know, it's nice, it's typed, and you know, if I was to call this, I would guess that, or if I would just see this somewhere, I would guess that it does something like this. Okay, so you have your regular expression, you match the email against the regular expression, and if it looks okay, then you return okay. and if it doesn't match the expression, you return an error. So this is what I would imagine a function like that does. A pure function, very nice, very straightforward. But it might just as well do this. So, like maybe the person who wrote this, or maybe the person, someone got like a ticket on the Jira that said like, oh, we should not allow two people to sign up with the same email address, and so they added a database check, like a database call here in my function. So this user repository, does user exist, probably calls the database in some way. And unless I read this code when I called it, I could have completely missed this. As a matter of fact, I have multiple times. You know, you call something and like, you know, maybe you have you need to import like a huge CSV file of users, and you just call the validate email thing because you think it doesn't like do anything with the database, and then like, you know, you bring the whole system down. Even worse, we don't even know what kind of side effects it is. Like, if it was called user service instead of user repository, now we are in trouble, because, I mean, judging by the looks of it, this probably does like an HTTP call. Maybe I'm using one of those microservices I talked about that I introduced because my code was too complex. Well, now I have dependencies across different services instead. So, and if I call this in a hot loop, then wow, yeah, I mean, bad things will happen. Any questions so far? The audience, Discord? No? Okay, so, and I said, like, you know, this is where we are in functional programming territory now, but we still have these problems. So how can we fix this? Well, pure functional programming fixes this. So most of you might be familiar with pure functions, but just to reiterate, a pure function has no side effects. If you give it for a given input, it will always return the same output. And this is very nice because that means you can treat it as a black box. As long as you know, if you know that the function is pure, then you only really need to know what type you should call it with, and then you will know what type you will get back. So you only need to like understand the input and what kind of output you can expect. So if my function says that it returns an int, it should always return an int. However, you know, we live in a practical world, right? We're not getting paid, you know, just to write white papers and stuff, at least not most of us. So the functions actually do need to do something with the outside world at some point. So one strategy we can apply to sort of maximize the amount of pure functions in our code is to try to like have a clean separation between pure and impure functions. And one strategy is to move all the I/O operations to the boundary of the program. I won't have time to like go through all these techniques in details, but there's a great talk by Gary Bernhardt about this, or it's more like a presentation, but it's called like imperative shell and functional core. The idea is that you push all of your I/O operations to the like edge of the program, and then have a core of like business logic where like the most interesting stuff happens, and that should be all pure functions. Another really good example of this is like what's called like functional reactive programming, where you model all of the side effects as events. So if a side effect completes, that means an event is generated and that gets passed into the top level of the program, and then some computation happens which can result in a new event or a result, etc., etc. And React and Elm and Redux are great examples of this. So for some problems. They are appropriate solutions. And something we need to remember is that purity is transitive, which means that a pure function is pure only if it calls other pure functions. As soon as you introduce some kind of like impurity, it spreads. It's like a crystal. You drop it, in the water and like poof, something like it just starts spreading. Okay, so this is one strategy. Another strategy, which is quite popular, is to use dependency injection, which basically means that you have like all of the side effectful things in your program are like classes or objects that you inject into functions. So whatever a function needs to do something with the outside world, you put a dependency in the argument list. And if you flip this on its head, you get something called like an effect system, which is popular like in the Scala and the Haskell and also the F-sharp world to a certain extent, which means that instead of taking the side effectful things as function arguments, it returns a value that will later, be resolved into another value. It's kind of like promises in JavaScript. So, like instead of returning a value, you return a promise, which is like a deferred value. So, and then that gets returned back to the edge of the program and gets resolved into a value. And we will see some examples of this later. Anyway, the point is that this lets you tell if a function is pure or not, depending on the type signature. And this works really well in typed, like statically typed languages, but it also works pretty well in dynamically typed languages, because even though dynamically typed languages don't have type signatures, they still have function signatures. So it's still kind of obvious, or at least it's very visible, in the code, if a function needs to perform side effects. Let's see. Yes. Okay, so if we fix the validate email example a bit, so here you can see that it takes a user repository as an input argument. And that makes it obvious from the type signature that, this function will perform a side effect. But it cannot do that until I have provided an instance of this user repository. So that's a nice way to, both be able to swap out side effects, but also make it obvious that this function is not pure. Another nice bonus that we get is you can see what kind of side effect it is performing. And then you as the programmer can make a judgment call, am I using this piece of code in the right way? If I see that it's calling the user repository, that's a database call. That's not too bad. It's reasonably performant. If it was called iUser service, then you might be a little bit more cautious. Okay, this is probably an HTTP request. It's going to take a little bit longer to complete. And then, of course, the darling of functional programming, Haskell, I think is pretty good, to use as inspiration, because there the type system enforces a clean separation between pure and impure functions. Because in Haskell, you cannot just perform I/O. You can only do it in something called the I/O monad. So every function that uses a side effect will return an instance of the type I/O. And you can also do this in other functional programming languages, of course. So this is some code from the F-sharp code rewritten to use an effect system. It's similar to the Haskell code, but a custom implementation. And I don't really have, unfortunately, I don't have time to show you how this works, but at Func Prog Conf, Daniel had a very nice presentation about effect systems in Scala. So when those videos come online, you can watch that. But anyway, to sum up, like our goal should be to enable something that's called equational reasoning. And what it is basically it lets us treat programs as a mathematical expression. And you can think of it like kind of as a programming by substitution. Like every function call, for example, you should be able to substitute with an instance of the return value of that function. So like the way we should be able to think about our programs is as if it was a math expression. So when you're doing math, for example, if we have this 1 plus a greater than a, we should be able to remove a from both sides of the equation, which should give us like 1 is greater than 0, which should always be true. And the big unlock here is that we no longer need to care what the functions do. We can just look at the type signature or look at the documentation description, etc., and just trust that they do what we think. And just to sum up, if we remove side effects, if we remove null and a bunch of other things, we can unlock this mode of programming called equational reasoning, which lets us treat functions as black boxes where we don't need to care about the contents. And something as simple as 1 plus a greater than a should always be true. And this allows us to only care about the part of the program that we're actually working on right now. And I can say this, as in my day job, I do F#, and at our job, we're very strict about separating, side effect full functions from pure functions. And it really is true. I usually just jump right into the code base, start changing stuff with complete confidence that it's going to work. Because of course, I also have a strong type system to help with that. But in the real unlock is, the separation of pure and impure functions. And if we manage to achieve this, the cost of change doesn't increase with the size of the code base. I just made this graph up, this is not real data, but we can sort of imagine that it would kind of look like this. Cost of change, of course, like a brand new project, it's still going to be easier to change things. You still need to understand not all of the code base, but a lot of it still. But we can say that progress should not taper off as quickly. And like I said, this is 100% anecdata. I don't have anything to back this up. I just have lived experience. The rest I pulled out of my, USB port. Hopefully you can use this to convince your boss that functional programming is a good idea. If anyone asks you, a relative or a close friend, why functional programming is important, hopefully you have some material so you can convince them. And finally, I really like, not having to have a lot of context when I change my code. I like being able to relax at work and not think too hard. But who else likes small context windows? Yeah, my friend Claude really enjoys those. And I think this is some people say that, when we have coding agents, the choice of language will not matter anymore. But I think we could get the complete opposite effect. That just like a human, if Claude needs to understand the whole code base just to make a change, of course it's going to perform worse. And you can see that the coding agents, their default mode of operation today is to just they do a rough scan of what they think they might need, what code they think they might need to read. And then they suck up the whole files But given that they can work in a programming language that supports equational reasoning, this shouldn't need to be the case. It should be able to pull in just the context it needs, like, oh, I just need the types or the documentation for this function, and then I can modify it without fear of, like, doing something crazy. And then I can spend its context on more like sensible things instead of like just digesting all the files in the entire repository. Yeah, that's it, everyone. Thanks for listening.
Thank you very much, Christoffer. Thank you very much. So, do we have any questions in the audience? Not so far. I'll shoot one question, Christoffer.
Yes.
How many times have you run into this? That your passion for functional programming or for pure functions. How many times have you run into functions that are not pure, that have caused you issues?
More times than I would like to admit.
Okay.
No, I mean, like I said, one time at a previous job, which I will not, for fear of lawsuits, etc. I did do that thing where I thought the function was like, had no side effects, but I called it in a loop, and it caused huge performance degradations. But I think in general, just the confidence to know that, like, I mean, I would say the huge big cost is not really incidents that are caused. I think the cost is the work that you have to do as a programmer to make sure that this doesn't happen. And I think we can also see this, like, to our credit, I think programmers, as a profession, we are very diligent. We don't like it when our programs crash. And so what happens when we are not sure that a function works, we invest a lot of time in trying to understand how it works. And we write unit tests, and we have QA, and we have integration tests, etc. And basically, none of these things would be necessary if you could sort of like just prove out that, well, the program does work in this way. I think that's, so to answer your question, I mean, that doesn't happen very often. But on the other hand, I spend a lot of time trying to ensure that my code is not doing something unexpected.
So you would say or argue that if you do functional programming, you need less Q&A?
I would almost say that...
Test or call it test Q&A?
No, I would almost say that I know so.
You know so, okay, interesting, yeah.
Because, I mean, I've been on the other side of the fence. And, yeah, I mean, I've written code that sort of like crashes with the null pointer exception, etc. in production. So these are real problems.
Cool. Now, do we have any questions? Yeah, we do.
Other side of the pillar.
Yeah.
So how important is it to you that you have a functional programming language to support this? Because personally, I agree with like everything you're saying here, but mainly I use TypeScript to do the same things, and then you don't have the same guardrails as with the functional programming language. But I still think that you can get a pretty good structure according to what you say.
Okay, so the question, I don't know, did we get the microphone? Okay. So I mean, I kind of could have spent a bit more time on that in the presentation, but there is, for example, an effect system for TypeScript called effect TS that sort of tries to get these things under control. So you get like managed side effects. I think it also has some support for result types, etc. So, and there's the same thing, like, C# has the language ext package that you can use to program in a more like functional style. I mean, that said, sometimes you sort of have to be practical as well and know when you are sort of going against the grain too much. I mean, the functional programming paradigm works best in functional programming languages, no surprise there. But I mean, you can sort of pick and choose, I think. Like you can sort of see, maybe you don't have a huge problem with exceptions, for example. Then you don't need to invest a bunch in, like, you know, adding result types to your code base, etc. But I think, like, and maybe, you know, some programs are just very pure by nature. For example, maybe you don't need to like send, or maybe you don't need to call that many side effectful functions. Like maybe it's a few database calls here and there, and then you don't really need to invest in like an effect system or dependency injection. Like, you know, I usually think of it like if you try to solve a problem you don't have, then the solution becomes the problem.
One more question.
I just want to share a thing that I developed a very big website. Complete website was inheritance based, and a one plugin which was developed by a previous person, I just extended it, and it was function based complete plugin. And then audit happened on the website, and they said that this plugin should be changed to inherited. And now I'm thinking that might be if we change from functions to inheritance for this plugin, might be new problems can arise.
Yeah, I mean it's like I said, some code is written in like a very like object-oriented style, for example. Then it's very hard to swim like upstream and try to fight against that. Same thing with like effect systems. If you call a lot of libraries and you want to use effects, then you have to wrap all those in your own effect library, etc., etc. So, yeah, I would say it depends. There's no silver bullet.
Yeah, and yeah, we do have more questions.
Hi, thank you for the talk. What would you recommend for sort of I/O needs, but which are iterative? So that imagine you have a backend function which you've been called an API, and then you make an API call, and I need to make another call to another service, and another one, and another, depending on the business logic. Because you cannot make all the API calls ahead of time and do this I/O isolation and the functional core in reality, because there is a cost to it. So how would you recommend to approach this problem?
Yeah, that's a very good question. And I think, like, you know, a lot of the time when people talk about pure functions, etc., and they recommend this like function core imperative shell pattern, they sort of dodge that question, like you just asked. Like how, if I have like a sequence of I/O calls, I need to use one value as the input to the next side effect, and maybe there's some kind of like conditional logic in there as well. I mean, then this pattern starts to fall apart. But I would say, like, either you can still leverage dependency injection, for example, works very well for this use case. And then depending a little bit on like your language, then using an effect system might be appropriate as well. Because basically, like I said before in the presentation, they are essentially the same, or they're not really the same thing, but they are very similar. Like it depends on whether you want to accept the side effects of function as an argument, or if you want to return it as a type. Did that answer your question?
Yeah, but it essentially makes you to write a code inside out to some extent.
Yes. Yeah, I think the problem with like the problem with side effects and things like conditional logic, etc., is that it always forces you to turn the code inside out. Even the Haskell example is, you know, code turned inside out, except that it's made less visible due to language support. But yeah, and this is why I'm saying that like effect systems might not, like effect systems work best when you have a language that has good support for monads, like Scala, F#, Haskell, etc. Otherwise, like dependency injection is probably more appropriate.
Thanks.
Like another thing is kind of overseen or not, like you have a responsibility of making the code such that fits the paradigm. So sometimes it's just like I got used to writing my code this and this way, and why this language or library doesn't support that. And sometimes it's actually like needs a bit of time to like click the new paradigm, and then it just flows. And then like that's my kind of like experience, that once I get it, then it actually becomes easier and I don't end up on the same kind of problems. And most of the time I realized that maybe my logic was flawed in the different paradigm also. I was like, oh shit, I actually haven't seen this. So it helps me to like re-evaluate how I tackle a problem.
Yeah, thank you for the talk. It's not a question, more a remark that the examples that were in the beginning with the side effects, there are non-functional languages where that situation would not be possible, that have optional types or like functions that the signature include the optional error type. And for instance, if the function returns the optional type, like optional int, you cannot just assign it to the int variable. It would be an error on the compilation time. So just a remark. That's not just functional.
Yeah, I mean that's a good point, because it's like, you know, and it raises a philosophical question as well. Like, you know, what is a functional programming language? I mean, Rust, for example, isn't. I wouldn't call Rust a functional programming language. At the same time, Rust doesn't really suffer from most of these problems either. So, I mean, some people are very strict. What they like, to them, functional programming is like a direct descendant of the lambda calculus that can be used to prove theorems. But if you have a more liberal interpretation, like functional programming is like a set of shared aesthetics. And that's sort of more the way I think about it.
Yes, given that you like, I really like all of this, and I think it makes it much easier to code as well. But given that you're already like have a code base that's not like this, have a bunch of like lots of side effects and global variables and mutability, do you have like any experience or tips for how to approach, like given that, how can you move towards this?
I think the best way is to tell your boss that we need a code freeze for 12 months while we fix this. And I'm sure that they will agree. Like, yes, of course. No, but seriously, I think the way to approach all kinds of rewrites is sort of to do a little bit at a time. I'm a huge believer in you know, lean software development. So like I said, if you have a problem, and like given that you actually have a problem, solve a little bit of the problem as fast as possible, ship it to prod, and, you know, learn from the experience. Because I think a big mistake that a lot of people make is that they get this, you know, they learn about this cool new thing, then they go off, and then they sort of rewrite a service or write a new service using this technique, which they have never tried before, and then they ship it, and, you know, it's just a complete mess. Because it's like I said, there are no silver bullets. There are no techniques that are like magically better than something else. Like everything, all techniques you need to learn everything. Like basically you cannot just add functional programming and it will make everything better. You have to add functional programming with taste. So I would advise that you sort of first of all start with something that is a real issue, and then try to solve that incrementally. Ship the smallest iteration possible, then keep going. Like, you know, if eventually, if this thing works, it starts building momentum. And doing that other thing, like, you know, going away and rewriting a service and then shipping it, and, you know, it's your colleagues don't understand it, it doesn't work, etc., etc. That's a really good way to sort of kill functional programming at the company before it even had a chance to, you know, before it even started. So yeah, that would be my advice.
Cool. Any more questions? No? Then we end on that. Thank you very much, Christoffer, for your presentation.
Yeah.
Yes. And no one asked Christoffer if he likes Emacs or Vim the best. So we're not going to do that. Unfortunately, you missed your chance.
Just use VS Code. Just be a normal person. It's too late for me already.
Yeah.
I wasted my youth learning Vim. Don't repeat my mistakes.
Okay, thank you very much, and thank you everyone online for that. Goodbye. Cheers.